In today's episode, we will be discussing architectural patterns in software. Hey, what's up?
I'm the Coder Kid.
And I'm Mr. Miyagi, and welcome to our show.
So let's start with in-tier architecture, or as some will call it, layered.
Okay, yeah. So basically, interior architecture is any type of tier that your business system consists of. You can have a 2-tier architecture system.
Yep.
You can have a 3-tier architecture system, or you can have basically what it says, in-tiered. But most popular architectural systems utilize a 3-tier architecture system.
So what's the definition? The definition
okay.
for it. So for our viewers,
right.
So
a 3-tiered architecture is basically a system that consists of a presentation layer, a business or service layer, and then actually a data layer.
Right, a 3-tier.
3-tier, yes, yep. Yes. So basically, presentation layer. We can discuss that one first. Basically, your presentation layer will consist of all of your front-end frameworks that we discussed in the last episode, Angular, Vue.js, or React.
Right.
There is old school MVC and Razor, but that's primarily what your presentation layer consists of. And then you have your business layer, which consists of business model objects,
Right, some business logic up in that layer.
Well, I didn't want to. I just want to say that it consists of business model objects and business rules.
Right.
Yep. And then your data layer, which is the 3rd tier, is where all of your access to the database.
Right.
Where everything takes place. All of your whether you're using Entity Framework or you're using stored procedures or embedded SQL. That's where all of your database calls will reside.
Yep.
So let's talk about the presentation layer first. Like we said in our last episode, we talked about some of the popular frameworks, but the presentation layer is the first part of an interior architecture.
Yeah, so that's what your end user is going to see.
Mm-hmm.
So just like it sounds, presentation layer. So if you're an end user, when I go to websites, I go to on mobile applications. That's what I see is the presentation layer.
Right.
I have no idea what's behind the scenes, except I can see the presentation layer.
Exactly.
I think that's an easy description.
Yeah, pretty simple. Yeah. And then once you get past the presentation layer, then you have your business or service layer. And in your business and service layer, that's where, like we said, we have all of our business decisions that need to be made. So let's just give a scenario if, we're going with customer again. So in our presentation layer, someone's requested customer information. Mm-hmm. So from there, you may have a service layer that makes a call to your data layer to return the customer information. But we want to know more about that. So let's just say, we're on an e-commerce site and we want to know your last 5 orders that you have.
Transactions.
Yeah. So, we would pull that in and we look at your last 5 transactions, and maybe we want to know how much money you've spent on the site so far, because if you've spent a certain amount of money, we might want to give you a 10% discount. Right. So all of these business rules would be in this service layer to construct an object model of a customer and return it to the presentation layer.
Right.
So go ahead. You want to talk about the data layer?
Yeah, the data layer. So kind of we touched on it there, where these business rules exist, but where are they getting this data from? Right. Where do these transactions exist?
Yep.
It's in the data layer. So traditionally a database, a storage. But I've seen there are some applications. It doesn't have to be a database. It could be some text files or something like that.
Yep.
Not recommended.
No,
no. But it's possible, and it still serves as that data.
But you could have a small company that doesn't really need a lot of data. Yeah. They may have a JSON file. I mean, just a big scripting file that has all of this data for you.
But it's still your data tier.
Right. So it depends on the size of the company. It depends on the size of your application. But what rules do you think should be as part of the data layer? In my opinion, it's widely accepted that the only thing that should happen in the data layer is for you just to pull data, just to request it.
Yeah, just
no business layer logic or anything like that should reside in that layer.
No.
So it's very concise. This three-tiered architecture really organizes your application. It separates it out into different areas, and it's easier to maintain. And every layer has a certain responsibility.
Right. Yep.
So, Drew, do you have any disadvantages that you think are to this approach?
Yeah, I think one major disadvantage is probably the uptime for it. So if you're a new developer or a solo developer, it can kind of be a lot of work to get this up and running as a in-tier instead of just putting it all on one layer.
Right.
That can kind of be a little more complex.
Yes.
But there's not really many cons to it that I see. I think if you're going to be in software development, you're going to see an in-tier architecture.
Right.
At least once.
Yeah, and I think a disadvantage is that, if you don't have developers that are seasoned in that type of architecture or design pattern or anything like that, then the ramp up time does take a lot longer. Right. Junior developers who have never operated in this space, it's a new mindset, so they could struggle there. But I think a mixture of senior developers and junior developers to mentor.
Which you should have probably.
Right, which you should have. So. But those obstacles can be overcome fairly quickly. But definitely a great approach to software design. You usually see a three-tier architecture system in e-commerce applications or any type of database-driven site.
So what's some pros to an in-tier?
Pros to an in-tier?
Or three-tier
pros? Yeah. Well, when you have a three-tiered architecture system, you have logic that is separated and it does only what that specific area of responsibility is supposed to do, which makes it easier to maintain.
Yep.
If you need to update the business layer with new business rules, that one particular part of your application is being updated, and you're not touching your data layer, you're not touching your presentation layer.
And you can kind of separate out developers. They can work on separate pieces instead of being in this one spaghetti code thing. And that's when you run into a lot of merge conflicts and stuff like that. It could be disastrous.
And I think that a lot of, and you see interior architectures in monolithic systems.
Yeah.
And when a company is just starting out, a lot of developers who don't know the interior architectural approach will put everything in a method, the call to the database, the business rules, they're all in one method and
not separated.
Right. And when you need to update business rules, that one method could really, really get to bloat to many lines of code.
Yep.
So, keeping this approach intact and using it will definitely help separate areas of responsibility. It'll make code easily maintained. And like you said, you can distribute the work amongst your developers. That team A is responsible for this, team B is responsible for that. It just brings order and structure to your development process.
Right. Yeah, I think if you're not doing interior, at least interior architecture, definitely ask the question why.
Right.
I think it should be pretty common practice at this point.
Right. And the beauty about interior architecture is that it's not just for monolithic systems. You can take this approach and you can apply it to microservices, distributed systems, service-oriented systems. And we'll get into that in just a second.
Yep.
But in my opinion, an interior architecture is it's kind of a old school of thought, but it works, and you can apply it to every single one of these approaches.
Right. Yeah, and that's kind of how they evolve. Like when we go into the other two popular patterns in this time, they've kind of evolved from that layer and just added more. It's kind of like layers of layers.
Yeah.
I mean, it's really just a bunch of interior, but they're called different, and there's some different differences between them, and we'll go into that.
right.
after this.
Well, do you want to just dive right on into the next one, which is microservices?
Yeah, let's go into microservices. So with microservices, you kind of have these clients, which will be like your UIs. Say you have a web system and you have a mobile system or a mobile app.
Right.
And they both those UIs will point to an API gateway. And from that gateway, it'll kind of decide which service it needs to call based on your request.
Right.
And what microservice architecture is all about is kind of living in your own space. So you'll have a service and a database just for that layer a lot of times. I've seen some that are called microservices and they share like database and stuff like that. It's kind of more of a cost problem, and the more databases you get, because microservices is really heavy on resources. Like you're having a single database, a single service that runs by itself. That's the whole thing about microservices, is they kind of run in a silo by themselves, and they have their own. You can debug them, you can test them. They run completely by themselves. And what you'll run into a lot with microservices is repeated code. Because you're in a different service, but it shares something.
I was gonna jump into that because in a microservice architecture, you want loosely coupled objects, and you want loosely coupled components, and which breaks away from traditional object-oriented programming, and it's hard for people to kind of understand that,
that it's okay to copy and paste the code.
Yes, I've been at some companies where after I've gone through domain-driven design and that approach and stuff like that, I went to my next job and some of the developers were really heavy into object-oriented programming and shared libraries and I was like, oh, wait a minute, I truly believe in a microservices architecture and I go into that whatever job I'm at or that project knowing that some code is going to be duplicated, and that's okay. It's okay. Because if you're using a shared library and something about that shared library is updated and it just somehow got through the QA process and it was buggy, it's going to bring down everything.
All your services.
All of your services are down, and that's the beauty of microservices, is that each one stands on its own. And
which means that there are some pitfalls. So if you have common code in several services, since they aren't sharing anything, if you have to change something pretty significant in that one service, you most likely have to copy it over to the other services.
You may have to,
So that there is some pitfalls maybe to that extent. But I think overall there's just big advantages to doing microservice architecture.
Well, let's talk about deployments night. Deployments, when you have a release night, with monoliths, you have to, you used to have to, everyone come in, you bring the system down, you have to put up a maintenance page up on your site, while you go through maintenance and it's all hands on deck and everything gets updated.
And hopefully nothing goes wrong.
And hope that nothing goes wrong. And we've seen deployments last all night. And some of them even go into the afternoon because the deployment was not successful.
And that's something key with microservices, that they're in their own container, their own world, where you can just push that out. And that's all you're needing to test, is that little bit. There's not really any side effects. And also bringing up when you have an outage. Say one of these services for some reason goes down. It doesn't break your whole application. It'll just break those calls. Whereas in the monolith, if something goes down, they all live on that same server. So if it goes down, it's down.
And deployments, you when you want to deploy a certain feature that was an update to a microservice, your entire site is up. You may not have that specific microservice available to you, but the site continues to function. And it's all about uptime. Uptime. It's all about uptime, and with a monolith, you don't have that. You have to bring the whole system down. And companies today, they need that visibility. They need their systems up at all times.
And it does, like, it still makes sense to do a monolithic application, I think, for smaller
Right.
application.
Yeah.
And like one of the negative sides of microservices, or something we'll go into in a second,
Right.
service oriented,
Uh-huh.
they're costly. They're not cheap.
Right.
And a lot of organizations, especially smaller ones, can't afford that. They're
Yeah,
like,
and I
we
would.
got to have it living on one thing.
Right, and I was gonna. I'd say I'd take it a step further. Is that it also depends on the size of your company, because when you're a small company, or maybe even a medium-sized company, a monolith is really the way to go.
Right.
Because like you said, it becomes costly to deploy all of these microservices.
Yep.
And
then you turn into that phase where once you get to a certain point, you start taking it out and creating, like our one company that we worked at together. That's the whole reason we were there,
right?
To kind of
to take that monolith and start separating it out into
that got them through the first 5-10 years of their company, right? And they were just trying to win every way they could. It's a no-brainer once you have enough money and the resources don't matter.
Right. And there comes a point in time when your monolith outgrows your customer base, or when your customer base outgrows your monolith, and response times start getting longer and longer and longer, and your database is just bloating with rows and rows of data. And at that point in time, then you need to look at a microservices type of architecture,
And I will say there are some performance hits with microservices, because you have to communicate with the layers, and it's usually through REST. So you're having another way of you're going through the gateway, and then you're going. So one of the drawbacks to microservices would be the response time, since you're going through an API gateway, and then that API gateway will call another API, most likely, to get to that microservice. It does slow down because you're just going through more network. The networking, you're just going through another portal. So I did want to mention that it's very small. It's not a huge performance hit, but it is, and people do care about those things.
Right, and it's a small disadvantage, and it leads into troubleshooting. How do you the one of the disadvantages is troubleshooting, a microservice that has to go through several layers. And one of the important parts of microservices you have to make sure you have is that you have logging in each layer. If you have a gateway and then several services that comprise of an eventual save, then you need to be able to look at each service in each gateway's log to be able to isolate where the issue is, because you can look in a microservice log itself, and you may not even see that it got to that point.
Not even got there.
Yes. Yep. So you can either start at the very end, or you can start at the beginning, or you can start somewhere in the middle. And it's always standard practice to have logging at all places within your microservices. So
it's definitely a lot more you have to look through, because you separated these things out. It's not just like our interior approach we looked at.
Yep.
There's just so much more where you can have an error in. So when you're debugging and troubleshooting, it can be a little more maintenance, I guess.
Yes, a lot more maintenance.
Yep.
Well, let's go ahead and let's get into our final architecture we want to discuss, which is the service-oriented architecture.
Yeah. So with service-oriented, or you'll hear messaging. That's going to come up when talking about service-oriented.
Right.
So what you'll have is the same approach with the microservices, where you have these UI pieces, whether it's a mobile app or a web application, and instead of going through an API gateway, they'll still go through that most likely, but instead of going to a microservice itself, it's going to go in the service bus. So a thing that's called the enterprise service bus. And within that, based on your request types and your message that you're sending through, it tells it where to go. So it'll send it to a provider. And that can be like an account service, an order service, or a shipping service.
Right.
And then from there, it'll do the logic to, that piece, whatever it needs to.
Right. Whatever. If it's meant for saving, it's going to take that message and it's going to save your shipping information.
Right.
But it's all part of a messaging centric architecture that on the UI side, very simple. You fill out the information, you gather all the information that you need about shipping, and you push the button to save, and it configures a message and it just sends it.
Yep.
And there's no processing, there's no wait time for a response back from the service. It just sends that message out to the bus, and that bus eventually gets that message and it processes it and saves it. And that's where they start using these phrases of eventual consistency.
Yep.
And if you want to go further into that, let's go ahead and let's do that.
Yeah, I mean, it'll go into it'll send it to a queue, and it'll go in order from that queue, whatever was first and first out, right? So it goes in, comes out, and you may have a huge system, so that's where these architecture patterns that like service-oriented, like microservices come into play, because you have so much communication going through.
Right.
And on the UI, not everything needs a response. So something like a payment, maybe you don't need to know if that failed or succeeded right away. You're just going to be processing. And you can process for, however long. It won't usually take that long, because to go through the queue, based on how big your service is. It's probably not going to take too long, but it's also, you don't want to bog down the UI. So waiting for it.
And these messages, they're usually, when they're sent to the bus, they're usually processed within milliseconds or seconds. We're not talking minutes or 10 minutes or anything like that. These service bus architectures, they're pretty fast, and they process this stuff really quick. So and another really good advantage to this is that when you think of your web server and you think of your services that are on another server somewhere within your cloud, the processing load that you have on your web service is greatly reduced. Everything is quicker. All of that gigantic bloated server that handles everything, whether it's your database, your web server, your microservices, you can just stick your site on a web server, and processing is faster. Page loads are faster because it's not churning through waiting for a response or anything. It just makes everything faster. So it's a very highly used architecture at an enterprise level. You won't really see a medium or small size business use this type of pattern, although they could. But you normally see these in a big enterprise systems.
And again, that kind of goes back to what we talked about microservices being a con to it is cost and resource heavy. So these like enterprise service bus, we used in-service bus and RabbitMQ, not necessarily the cheapest things out there, right? So you have to kind of have an organization that's big enough and needs it, right? You don't want to just do it because everybody else is doing it. So at smaller projects and companies, you may not see this.
And you can even use Azure Service Bus, or you can use Event Grid. But let's talk a little bit about the types of messages too, because I don't think we really talked about that, and we don't need to go in too much detail. But normally there's two types of messages. You either have a command, which is something that a message tells a service to do, and then you have an event, which signifies that something has happened and something has changed. So those type of messages are the more or less standard of a service-oriented architecture. I don't think you'll see any other type of messages. You're just really concerning yourself with commands and events. So
and what an event will do is when it comes through, a command, you're kind of doing stuff to that, but when an event is published, it's like, hey, I paid this, let's send out this event. And a couple services might be reading for that. Maybe listening, reading. But listening for that event, and they'll be like, oh, this was paid, so I need to do my command, or I need to do my logic that says when I hear that, I do
Right.
this.
Or you could go back a little bit you can go back a step where if you're going through a credit card processing, you purchase something online and you're at the payment side of the process, and your credit card information is inputted. You've saved it, and an event goes off and says, okay, this charge has been approved on your card, right. So the charge has been executed. Now the event publishes a message out to the shipping to start the shipping part.
Yep. And email service. Maybe it sends an email to the end user. I know Amazon does that because I always get one when it's approved.
Right.
So, and when it's shipping, they also do the email.
This is some good fun stuff. I mean, talking about these architectures, it's really fun. And as a developer, you can't go wrong getting into either one of these three architectures. Right. It's these are widely accepted. They're very popular and widely used.
Right, and that's why we wanted to touch on these three and kind of look at your organization and if you need to move into if it's time to grow. Whether it's in tier, if you're not at an in tier, it's probably time to turn into an in tier. But even from an in tier to turning into a microservice or service-oriented pattern.
Right.
And then select the one that's for you, or I've seen hybrids of both.
Yeah.
So you can it's based on your needs of your organization.
Yeah, you usually tend to see, in-tier architecture starting to come into play when you've got a company that's small and they're transitioning from small to mid-sized companies. Then you need to start thinking about an interior architecture and going in that direction. And then as you start to grow close to the enterprise level, then it's really time to start thinking about microservices and SOA. It all depends on your growth and the type of business you have, and just fun stuff to consider. Your developers that are on your team, they're going to love it. Most developers love a challenge.
I definitely liked it when I went into distributed system stuff.
Yes,
I liked it. Enjoyed doing it. I'm not doing it currently. I'm on a little smaller projects. But I'd love to get back into it at some point in my career. So.
Oh yeah.
So we'll end that there. I think that's a good note.
Yeah. So. Good stuff to go over, and let us know what you think in the comment section, and give us your input, what you think, and
let us know if you want us to go deeper in one of these, or we can definitely do that. As well.
Yeah. I mean, we covered just high level stuff, and if our subscribers want more depth and more information about a particular architecture, we'd be more than happy to do a video on that.
We'll expand.
Yep. All right. Well, have a good day.